Hey everybody, Ms. Ortiz here, and I figured that we might have some questions about the energy equations that are outlined in study section 2.1.3. So I thought I would record examples for you to watch. The first of these examples is going to be the equation for gravitational potential energy, and that's abbreviated as GPE. The most abbreviated version of this is represented by M times G times H, or if you're feeling fancy, just MGH. But I'm going to break it down so that it's easier to see where everything goes. So if we recall, the idea of gravitational potential energy is related to how much mass an object has, how far it is from the ground, and then our special sauce is going to be the force of gravity on that object, which remains the same. Since we use SI units for everything in chemistry, mass of our object is going to be in kilograms, height of our object is always going to be in meters, and the force of gravity is 9.8, and then the unit on that is meters per second squared. It's important to remember that this 9.8 is a constant. The force of gravitational energy from the Earth is constant or near constant for the entire planet. The next thing that we are having an example from in Apex is kinetic energy, and that's represented by KE. To figure out how much kinetic energy something has, we use the equation 1/2 times mass times velocity, and that's always squared. When we're calculating kinetic energy, we always use mass of kilograms, and our velocity is always going to be in meters per second. This is a really, really good time to discuss how do we break down a question. Well, whenever we have a word problem, as many things in chemistry are going to be, we have to have some sort of strategy for coming to an answer for whatever it is we're trying to figure out. And I call my method consummate S, consummate. The first step is strategy. When I'm thinking about strategy, I'm thinking about what is this question asking me and how the heck am I going to figure it out? The next part of my method is called setup. To set up my problem, I need to figure out where in this word problem am I getting my information from, and then where the heck do I plug it in? Then in my third section, which I call solution, I've plugged all my numbers in, and then I just do the math. Lastly, I'm going to take a second and ask myself, does this make sense? Strategy, setup, solution, and sense. 4 ways to make sure that I'm doing a problem right. For our first example from Apex, let's consider this. A ball with mass 1.9 kilograms is moving forward with a speed of 5 meters per second. It is 5 meters above the ground. Calculate its KE and PE, which is greater. So what should my strategy look like here? The first thing I have to ask myself is, what the heck is this question asking me? Well, the final question here is, which is greater, its KE or its PE? So to be able to answer this question, I need to be able to calculate both KE and PE for this question. Luckily, I have all the information I need to be able to solve. So let's start pulling things out. I've written both of the equations that we have from Apex about KE and then gravitational potential energy. Remember that later we are going to be talking about chemical potential energy. So I always put the G in front so I don't wind up confusing myself later. To be able to answer these, I need to know the mass, the velocity, the force of gravity on Earth, and the height. From here, I know that the mass is 1.9 kilograms. I also know that my speed or velocity is 5 meters per second. I know that my height is 5 meters because it says 5 meters above the ground. Then lastly, I know that G is going to be a constant, and remember that that constant is equal to 9.8 meters per second squared. So in my strategy, I figured out all the things I need to know and figuring out what the heck this question is asking me. I'm going to take all the stuff in pink and I'm going to copy it over to the next slide. See you there. All right, I've copied everything relevant over from that last slide. And now I got to decide which one I want to do first. I'm going to decide to calculate its gravitational potential energy first. So the equation for that is gravitational potential energy is equal to the mass times the gravitational force of Earth times the height. The next thing I need to do is figure out what goes where. This is my setup. Okay, so now I know that my mass is 1.9 kilograms. I'm going to put that in. And I know that the force of gravity on Earth is equal to a constant of 9.8 meters per second squared. Almost forgot to add the squared on my list over there in pink. The next thing I know is that the height of the ball above the ground is 5 meters. No naked numbers. Every number has to have a unit or else I have no way of knowing what makes sense or what doesn't. So now I know that I have to multiply 1.9, 9.8, and 5. All right, 1.9 times 9.8.5, or times 5, is 93.1 joules. So in this slide, I've done my setup, and then I've come to a solution by multiplying those things. As you get a better sense for what things should look like, it's a lot easier to decide whether or not you did something right, because in that sense-making step, what you should be doing is saying, does my final answer make sense? For example, if I divided something instead of multiplying it, my number would be a lot smaller than I expected it to be. We'll talk way more about that as we continue to move forward. All right, so now I know that the gravitational potential energy for this ball is 93.1 joules. I'm going to take that information and write it down, and then I'm going to go on to the next question as part of this question. And because I'm probably just going to be comparing two very similar numbers to each other, I just rounded 93.1 down to 93. Now the next thing I want to know is what its KE is, or its kinetic energy. The equation for KE is 1/2 times the mass times the velocity squared. All right, I've written both of these things down. Now I want to go and see where I'm going to plug these numbers in from the information that the problem was giving me. I know that the mass is equal to 1.9 kilograms, and the velocity is equal to 5 meters per second. So my strategy then is to multiply 1/2 times 1.9 times 5 squared. Don't forget your order of operations. We always want to make sure we're doing our exponents first. So I know 5 squared is 25, and now I can multiply it by 1.9 and then by 1/2. My final answer is 23.75 joules. And I'm going to go ahead and round that up to 24 joules. I've done my strategy by figuring out what numbers come from my information in the question, my setup by looking at the equation, making sure I've picked the right one, and then I've gotten to my solution by doing the math. But I'm not done yet. The question didn't ask me what was the gravitational potential energy and the kinetic energy. The question asked me to calculate its KE and its PE and then tell me which one is greater. All right, so my kinetic energy was 24 joules, and my gravitational potential energy, or PE, potential energy, was 93 joules. Which one is greater? The answer is the potential energy. That's going to be it for this video. In the next one, I'll go over example 2 and 3.